Hi again! Welcome once again to my channel. This is Binnacle Project.
Binnacle Project.
Today I bring you a new exercise to help you consolidate the matrix operations. But as you can see on the thermometer, we are still on orange zone, so there is still a long way to go before we reach the green one. As always, add this exercise to your notebook to go over it when you're preparing your exams. Stop the video, read the statement and try to do it by your own. I will put in the comments box the minute where I'm leaving the solution so you can check it out. And of course, if you are not sure how to tackle it, please come with me because it will be a pleasure to help you. Let's go. Let's read together the statement. It says, given the matrix A, and there you can see that it's a square matrix, order 2, 1, 3, -2, 1, find all matrices B that commute with it. Well, the fundamental idea of this exercise revolves the fact that, in general, when you're multiplying two matrices, A multiplied by B is not equal to B multiplying A. The old commutative property doesn't exist in matrices. However, if matrix B is properly designed, it could be possible to find that A multiplying B is equal to B multiplying A, but it is only if we are designing matrix B properly. And of course, it is precisely what we are going to do. Let's go. Matrix A is 1, 3, -2, 1. And as we don't know how matrix B is, we are going to put A, B, C, D. And we are operating to find the values of these four parameters. On the right side, we are going to do the same. Matrix B again, A, B, C, D, times matrix A, 1, 3, -2, 1. And we are just multiplying both sides to equal every... Now we're going to multiply. Why did I use a 2 by 2 matrix? Well, in reverse. You might have noticed that the dimension of matrix B, I've used a 2 by 2 matrix. But why did I do it? Because matrix A is also a 2 by 2 matrix. So it is necessary that the inner subscripts are the same in order to proceed with the product. But as on the right side, we are going to multiply these matrices in reverse, it is necessary to do the product on the right side that these outer subscripts are also the same. So that's why I've decided to use a 2 by 2 order matrix. And now it's time to multiply on the left side and on the right side. Let's go. We will have an order 2 squared matrix and position 1, 1. Row 1 of the first matrix, column 1 of the second. 1 times A, and 3 times C, 3C. A plus 3C. Second position, row 1, column 2. That is, row 1 of the first matrix and column 2 of the second. 1 times B is B, and 3 times D, 3D. B plus 3D. Third position, row 2, column 1, that is, row 2 of the first matrix and column 1 of the second. Negative 2 times A is negative 2 times A plus C. Negative 2 times A plus C. And finally, row 2, column 2. Negative 2 times B, negative 2 times B, plus D, plus D. That's it. And now, the same procedure on the right side. We will also have an order 2 square matrix with 4 positions. And position number 1, row 1 of the first matrix and column 1 of the second matrix. A times 1, A. B times negative 2, negative 2, B. A minus 2, B. Second position, row 1st of the first matrix, column 2 of the second matrix. 3 times A, 3 times A, plus B, plus B. Third position, row 2 of the first matrix and column 1 of the second one. C times Y, C times 1, C, minus 2 times D, minus 2, D. And finally, row 2, column 2. 3C, 3C, plus D, plus D. That's it. And now it's necessary to consider that if you want two matrices to be equal, it will be necessary to equate all the positions. We're going to do A plus 3C equals A minus 2B, right? Second position, B plus 3D equals 3A plus B, right? Third position, negative 2A plus C equals C minus 2D. And finally, the fourth position, negative 2B plus D equals 3C plus D. That's it. Now we have 4 equations with 4 unknowns. This is a very typical situation in math, but also in chemistry when you are balancing equations. How are we going to proceed? Let's simplify the 4 equations as much as possible. Look, the first equation, we can eliminate the unknown A. 3C equals negative 2 times B, right? First equation. On the second equation, we can also eliminate the variable b. 3d equals 3a. And we can also eliminate the number 3 that is multiplying on both sides. Third equation, we can eliminate the variable c, and we have negative 2a equals negative 2d. And we also can eliminate negative 2 on both sides. And finally, on the fourth equation, we can eliminate the variable d, and we have negative 2 times b equals 3 times c. And let's go ahead cleaning up the fourth equations, because I can see that the first equation is the same as the fourth, so we can eliminate one of them. And also, the second equation is the same as the third, so we can eliminate one of them. The final result of our calculations is 3c equals negative 2b, and d equals a. d equals a. This is our result. And now it's time to present the solution. You know that matrix B, that is A, B, C, D. What is God telling us through these expressions that are necessary for matrix B to commute with matrix A? God is telling us that position 1 must be equal to the fourth position, that is, position 1, 1 equals the position 2, 2. Let's use the same variable for these positions. And what about the second and the third position? Well, we can say that C equals negative 2 times B divided by 3. So let's use here variable B, but in the third position we are writing negative 2 times B divided by 3. And this is the result. As you can see, there are infinite solutions that depends on variables A and B. So we can say that this holds for every values of A and B real numbers. We could pick two values for A and B and present the solution with a little example. For example, tell me one number for variable A, let's say 5. And tell me another number for variable B, let's say 6. The final example would be matrix 5, 6. Negative 2 times B is negative 2 times 6, that is negative 12. Divided by 3 is negative 4. And finally, 5 again. This is a little example for our solution. I challenge you to multiply matrix A and B, and you will see that you obtain the same result as multiplying matrix B times A. But it is because we have designed the matrix B properly. But in general, in matrix, you cannot find the old commutative property. As always, please don't trust you've understood my explanation. Try to solve the exercise by your own. And don't forget that I will always be here to help you. Rock and roll! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!